Alright, so today we want to work on modular arithmetic. Modular arithmetic. Modular arithmetic. Now, modular arithmetic, which is sometimes called clock arithmetic, is a system of arithmetic in which numbers wrap around after they reach certain value. Numbers wrap around after they reach certain value. Modular arithmetic, which is sometimes called clock arithmetic, is a system of what? Of arithmetic in which numbers wrap around after they reach certain value. They wrap around. Take note of this word, wrap around. So it involves only integers. It involves only integers. Now, take for instance, we divide an integer by 5. Possible remainders will be what? 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. When we are working on 5, the highest remainder will be 4. Because whatever we are working on will be minus 1 will give us the highest value that we can get as the residue or remainder. So when we see this, it shows we are working on mode 5, or we can say modulo 5 or modulus 5. Now the plural of modulus is moduli. The plural of modulus is moduli. Also, when working on integer 3, I had to shorten this. What I meant to write there is integer. G-E-R, alright? When working on integer 3, what are the possible remainders? The possible remainders will be what? 0, 1, and 2. 0, 1, and 2. Why? Because when we are working on any integer, subtract 1 from that integer and you will get the highest possible value of the residue or remainder. So, just as we name this mode 5, modulus 5, modulo 5 or modulus 5, we can also name this mode 3, modulus 3 or modulo 3. So that's in general when we have a set of residues and we have the integer itself minus 1. This is m minus 1. We call this a set of residues for mode m. We call this a set of residues for what? Mode m. We'll call this what? A set of residue for mode m. We'll call it what? A set of residue for mode m. So this is the general. Okay? So when you look at 0, 1, 2, 3, 4, 5, 6, I put dot, dot, dot there. Dot, dot, dot there, meaning it continues in that manner. Meaning it can be 7, 8, 9 like that. Then it is indefinite. So we have m minus 1. This is the integer m. That's what we are working on. That's what we are working on. So to get the highest value of the residue or remainders, we subtract 1. I had to take a proper time to do this introduction so that in our next video, when I start to introduce calculations, you have a foreknowledge, a background knowledge. Alright? It is very, very important we discuss this introduction. Now, when we are writing, we say it's congruent to. We say it's congruent to. Now, let us take a look at this cycle. Now, look at this cycle. We have 0, 1, 2, 3, 4, and 5. This is a cycle. When in the beginning I said modulus arithmetic is a system of arithmetic in which numbers wrap around after they reach certain value. Now for this, when we start counting from 1, 2, 3, 4, 5, when we get to 5, we'll go back to 0. So it will wrap around after it reaches a particular value. So when it reaches 5, it will wrap around. That's for this chart. In some charts, it will wrap around at 2. In some, it will wrap around at 9. And like that, depending on the mode you are working on. So for this now, if you are very smart, you will notice that this shows we are working on mode 6. Because if I add 1 to the last value, it will show me the mode I'm working on. It will show me the integer I'm working on here. Just like this. If you look at this example I gave you here, look at it. While I was working on mode 3, go and look at the highest value. The highest value here is 2. Add 1 to it, that's 3. It will show you the mode. Go to the other one too. While we're working on mode 5 here, look at in the brackets here. What's the highest value? 4. Add 1 to it, 5. So it shows you are working on mode 5. Do you understand? So because this video is already 5 minutes long, I want to go to the next video so that I can explain this chart.